Of course. We're getting branded LinkedIn photos now.
Ah, that's
So
nice.
everybody's taking this thing where you get into the picture mention.
I'm good.
And they have like colored backgrounds. And you center it well on your best shot.
Yeah. So Martin actually, that's it's really nice.
And they have pink and yellow.
All right, we're getting started again. Please take your seats. All good?
Yeah.
Cool. All right, I'll hand it over to Paolo. We'll be talking about ahead of time compilation in React with Prepack.
Quite a mouthful, isn't it? All right, we're going to be talking about this long thing. It's not something we're using here at Trustpilot. It's just something I think it's cool. So let's start with a bit of a show of hands. Who heard about Prepack before? All right. I'm going to say it's like, oh shit. Where is it? Yeah. 20%? No. Who's using hooks? 70? I don't know. And who read the motivation for hooks in the? All right. Gonna go with something like 20. Totally scientific. Yeah. So actually, there's an interesting part which is about classes confuse both people and machines, and they start talking about how they want React to be relevant for the future and how they want to do ahead of time compilation like Svelte, Angular, and Glimmer, and that's kind of interesting. Like, how do hooks relate to that? And if you go and read like in the React issues about future goals on optimization, and there's this issue that starts, this is the final frontier for React, and it's talking about component folding. And yeah, I thought, let's look a bit into the final frontier. What is this about? So you already know this. I'm Paulo. I work here at Trustpilot. I'm in the same team as Naz. I did small contributions to Prepack, but just refactoring. I'm still figuring out how the hell that thing works. Yeah, and if you want to look at these slides, there's links and Twitter and all that. So starting to look like, what are these other platforms doing in terms of ahead-of-time compilation? One of the ones that talk most about it is Angular. They're implementing a new compiler called Hy-Vee. And this is like, their goal is to improve tree shaking. They want smaller bundles, and they also want incremental builds, so faster builds. This means that the optimizations they're doing are restrained to files. They don't understand the whole application. And basically what's happening is you have Angular and your templates going into the compiler, and the first component will get a big chunk of Angular that it needs, and the next one is going to get less of it. Yeah, basically you only need the parts, you only take the parts of the framework that you need. Then you have Svelte, which is a more extreme version of this, where there's almost no runtime. So the compiler is injecting all the functions to do DOM updates from the in the template. So it's basically just injecting a script tag that does all the interaction. And this is really, really fast. Yeah. And then Glimmer is one of the most interesting ones, because it implements a virtual machine. It uses handlebar templates, and it produces HTML and some numbers that represent DOM updates. So yeah, the HTML produced is very small because it's just this pretty much binary code that then the virtual machine is going to know that this number represents a certain kind of work, and this can be done in WebAssembly and so on. But all of these are using templates. And there's a relation here between how much you can optimize and how restricted you are. Like templates are much more restrictive than JSX, where you have like all the power of JavaScript to do whatever you want, right? And then in cases like Svelte, there's a point where injecting a little bit of code in each component is actually going to create more overhead than you're earning by doing this ahead of time compilation. Lazy loading can mitigate this, but it's still like in a large app is going to be a problem. So what does Prepack do? It takes normal JS and it produces JS that runs faster. They're much more focused on a fast runtime than on reducing the bundle size. Of course, you get both, but yeah, their focus is on speeding up the runtime. And it actually runs your code. I'm going to talk a bit about how that happens, and eliminates all the computations that don't need to happen at runtime. To do this, there's actually a full JavaScript spec compliant implementation interpreter in the library, and it has the special characteristic that it can track and undo operations to do these optimizations. So how does it work? I'm going to talk about 3 things that it does, all with beautiful names. First one is heap serialization. So Prepack is going to run your code in sort of a sandbox. It's going to check what happened in memory. Once your code has all the code that is running in the initialization phase has ran, it looks at the memory and sees what is there, what are the produced artifacts, and then it's going to generate code that produces the same artifacts but in a faster way. So here, for example, we have like a very contrived hello world. It's an IFI, right? So it's going to execute immediately. So it is initialization code. Once it's running, first you find this function. It has to be allocated somewhere. There's another function declaration, which is allocated as well in this scope. Another one. And in the end, we put the result of calling it in as a string in the heap as well. But now this scope is going to end, and the garbage collector knows that I no longer need those functions because it's an IFI, they can't be called again. So that's going to go out of memory. So what Prepack is going to do with this is just replace it with a string declaration. This gives a bit the same idea. If you're familiar with Rust, they talk a lot about zero cost abstractions. This is it kind of creates the same idea that you can have like a more complex abstraction and construct, and it's going to be compiled away to just what's needed. Another thing it does, it's a symbolic execution. This is basically how they handle everything that cannot be known, or things that cannot be known at compile time. So for example, if you're calling date.now, obviously you cannot, the date that when you build your code is not exactly relevant. So what symbolic execution does, it's going to analyze your code just like you would do with a math function. where you solve it to x being whatever is unknown in this case. So if you have different branches, like an if-else clause, which is based on this unknown value, it's going to figure out what is the value that is going to lead to one branch being executed or the other one, and optimize the different branches. So yeah, here in this case, like, well, I don't know, it's kind of a very simple example. So we know that we have a y value that we don't know, but we know that one branch is going to be executed when x is over 0 and the other one when it's under. So we can, or Prepack can deduce that if y is going to be over 5, we're going to have 5 or the other branch. And everything else was removed from the code. Another idea is abstract interpretation. Yeah, as it says there, it's about partially executing the program to learn more about it, and then removing, finding better abstractions that lead to the same results, and allows us to eliminate a lot of information. So an example is we have an array with the age of each one in this room, but what we actually care about is if we're all over 18 because we're serving beer or something. We don't need to keep all the information about the ages of everyone. We actually only care. We can represent something that is as relevant to our program just by having a Boolean instead of all that data. Yeah, here's an example of it. So, well, this is an example of both symbolic execution and abstract interpretation. We have a Fibonacci sequence. Obviously, that's expensive to run. We have a date.now, which we don't know at compile time. But we know, a bit lost. Yeah, there's a situation, if x is 0, we're going to want a Fibonacci of with 10 as the starting point. That's something we can execute at compile time. So in the end, yeah, we're still going to depend on that unknown value, but what is returned is just the value. It's no longer, the computation already happened at compile time. Oops. Now, if you're thinking of this is all like very pure cases, right? But when we think about classes, there's a few problems, right? One is that objects are passed by reference, so any property can change almost anywhere, right? Yeah, and any method, if you have a class in the global scope, any method might be needed. You don't know which ones are going to be called or not. So basically, if we have a class in global scope, it's going to have to be kept exactly as it is, even with a method we don't care about, because there's absolutely no way the compiler can know if this is needed or not. And then, of course, yeah, properties can change anywhere. Yeah, in this case, like I'm doing like an IFI, but if you think that function that is changing a property actually also depends on an unknown value, there's no way this can be optimized. Yeah. On the other hand, let's say that we have something, a function that returns something we don't know. And that is, depending on that number, we're going to execute one code branch or another. They are actually known. So we know like what each branch is going to return. So in the end, like we can optimize way more than we could if we would be using classes. So obviously this was kind of alluring two hooks, right? Prepack, besides most of the project is about JavaScript, but there's also like a whole part which is a React compiler, and it's basically the same ideas but applied to React. So this whole idea of component folding. So if you have several components which are not dynamic, they can be merged into a flat component that is, it would be very hard to work with it if you were writing it by hand, but it's going to execute faster, and yeah. And also if you have branching in your components, you can eliminate some of the paths that will never be used. So again, here's an example. Like we have this this component foo that will either give you an image or a span element. And some class coming from somewhere. And then you have the component that where you're actually using this stuff, where it is obvious that foo is going to be an image, right? I mean, you're passing a prop saying so. That can be optimized just to that, right? Like you no longer need the foo component or that CSS class. And if this seems like contrived, like just imagine that this one might be something coming from material design or from a parent library with a lot of stuff that you're not going to use. So in practical terms, this is something that you probably want to run after you bundle your code, where Prepack can have as much information about your program as possible. And there's already loaders for Webpack, Rollup, and so on. There's the VS Code extension and a Babel plugin for flow annotations. This is basically, you can use flow annotations to give more information to Prepack so that it can compile, optimize even harder because it knows more about your program. It knows, the types of these unknown variables. So what about when? There's actually, you can play with a REPL if you go to prepack.io, and a lot of these things already work. Probably it's going to start with React Native because the environment where this is being executed is a big problem, right? Like you can't be calling window.something or all the web APIs or all the JavaScript features that rely on the environment where it's being executed. Everything is going to be undefined because they're unknown values, right? But if we look at the roadmap, that's exactly what it says. Short term, it's React Native. There's some long-term stuff which is very interesting, like bug finding, right? If our program is, if the Prepack is executing all the possible branches and finding out the values that can trigger one branch to be executed or another, it might find combinations that will lead to the program crashing, and it can also be used to automatically generate tests that execute the different branches of your code. It does a lot, right? So it feels like this should be ready for production soon, right? Like we're almost there, right? But no. Actually, while I was preparing this thing, I was reading the README. In January, they added that the Prepack team is working on something else for now. They do say they're going to return, so let's hope so. And they have invested a lot of time in this thing, so hopefully everything will turn out to be okay. Anyway, do you have any questions?
What are the gains, though? It's like there are so many optimizations. Are there any numbers on what is the gain?
I don't think they have any numbers yet because this is mostly like experimental, exploratory stuff. But I mean, you will be eliminating a lot of code, right, and replacing expensive abstractions. Like, for example, if you do a map, it's going to replace it with direct object calls, which will be executed much faster. So I guess I don't know like what's the gain in percentage, but if all of this works, it should be significant.
Do you have any numbers on how long it takes to run this on like larger files? And can you cache running this? Because like if you're running Babel on a file, you can cache that exactly as is because it's just a module. But something like this with cross module boundaries and so on.
Yeah.
Are you basically left to running this from scratch every time you build for production? Or how does it work?
That's a great question. I mean, yeah, the first step of this is actually Babel. Like this gets the AST from Babel, but then like all the execution stuff, honestly don't know. Yeah, I also don't know if at which point you need to run it on every, like I don't think you would run this on your dev server, for example, right? Like you would probably run it on deploy because this acts over after bundling, right? And there's a lot of questions which I don't know, like source maps, like how the hell will this, is this going to be debugged, right? I don't know.
You
Yeah.
talked about they're going to continue working on React version of the library. What does that even mean? They're going to continue working on React specific version of Prepack or something?
No, so the Prepack, there's like a dedicated team to Prepack. Now they're working on something else, right? But there is like one module inside of Prepack, which is React optimizations. That's kind of a collaboration between the Prepack team and the React core team also participates on that. But I think like they see it as a whole, right? Like it's, they're gonna develop. Yeah, I don't know what the priorities are, but it feels like it's React Native, the priority, just because for two reasons. Like one is it's probably one of the easiest cases in terms of environments, and also they want to make it run as fast as native, right? So, but yeah, the rest, I don't know. Thank you.
Thanks, Paulo. And thanks to Trustpilot for hosting us. And I just want to reiterate that this meetup is very much a community effort. We have some grateful hosts that host us, but we also need speakers. So if you want to talk about anything related to React or just remotely in the area, it's always good to sometimes compare different strategies. Some people might be doing things differently, and it might